ಈಗ ನಾವು ಈ 4ನೇ ಪ್ರಾಬ್ಲಮ್ನ ಸಾಲ್ವ್ ಮಾಡೋಣ. ಇದು ಡಿಫ್ರೆಂಟ್ ಆಗಿದೆ. ಸೊ ಇಲ್ಲಿ ನೋಡಿ ಏನಿದೆ, ಎ ಪೇರ್ ಆಫ್ wheels of railway wagon carries a load of a pair of wheels of a railway wagon carries a load of 50 kN on each axial box acting at a distance of 100 mm outside the wheel base ಅಂತಾನೆ. ಸೊ ಹಾಗಂದ್ರೆ ಏನು ಅಂದ್ರೆ ಈ ತರ ಒಂದು ಎಕ್ಸಿಲ್ ಇದೆ ಈ ತರ. ಇಲ್ಲಿ ಏನಿದೆ, ವೀಲ್ ಇದೆ, ಆಕ್ಸಿಲ್ ವೀಲ್ ಇದೆ, ಇಲ್ಲೂ ಆಕ್ಸಿಲ್ ವೀಲ್ ಇದೆ. ಈ ಕಡೆ ಸೈಡ್ ಒಂದು ಬಾಕ್ಸ್ ಇದೆ, ಆಕ್ಸಿಲ್ ಬಾಕ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ಈ ಸೈಡ್ ಒಂದು ಆಕ್ಸಿಲ್ ಬಾಕ್ಸ್ ಇದೆ. ಇದ್ರ ಮೇಲೆ ಲೋಡ್ ಎಷ್ಟಿದೆ, 50 kN. ನೋಡಿ ಎಷ್ಟಿದೆ ಲೋಡು, 50 kN. ನೋಡಿ 50 kN. ಸೊ ಇದೆಷ್ಟು, 50 kN. ಇಲ್ಲೂ ಅಷ್ಟೇ 50 kN ಇದೆ. ಇಲ್ಲಿ ಎಷ್ಟು ಬಂದಿದೆ, ಇದು 1.4 ಮೀಟರ್ ಇದೆ. 1.4 ಮೀಟರ್ ನೋಡಿ, ಇದೆ ಎಷ್ಟಿದೆ, 1.4 ಮೀಟರ್ ಇದೆ ಅಲ್ವಾ. ನೋಡಿ 1.4 ಮೀಟರ್. ಫೈಂಡ್ ದ ಡಯಾಮೀಟರ್ ಆಫ್ ಆಕ್ಸಿಲ್ ಬಿಟ್ವೀನ್ ವೀಲ್ಸ್ ಇಫ್ ದ ಸ್ಟ್ರೆಸ್ ಇಸ್ ನಾಟ್ ಟು ಎಕ್ಸೀಡ್ 100 MPa ಅಂತ ಇದೆ. ಸೊ ಇಲ್ಲಿ ಸಿಗ್ಮಾ ಡಿ ಅಂತ ಕರೀತಾರೆ, ಅಥವಾ ಸಿಗ್ಮಾ ಬಿ ಅನ್ಬೋದು ನೀವು, ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ ಸಿಗ್ಮಾ ಬಿ ಇದೆಷ್ಟಿದೆ, 100 MPa ಇದೆ. 100 MPa ಇದೆ. ಓಕೆ, ಅಂದ್ರೆ ಇದ್ರದ್ದು ಅಲೋಯಬಲ್ ಬೆಂಡಿಂಗ್ ಸ್ಟ್ರೆಸ್, ಈ ಆಕ್ಸಿಲ್ ಮಟೀರಿಯಲ್ ಅಲೋಯಬಲ್ ಬೆಂಡಿಂಗ್ ಸ್ಟ್ರೆಸ್ ಎಷ್ಟಿದೆ, 100 MPa ಇದೆ. ಸೊ ಇದ್ರದ್ದು ನಾವೇನ್ ಮಾಡ್ಬೇಕೀಗ, ಈ ತರ ಒಂದು ಸ್ಕೆಚ್ ಹಾಕೋಬೇಕಾಗತ್ತೆ. ಇದು ಫೋರ್ಸ್ ಡಯಾಗ್ರಾಮ್ ಅಂತ ಕರೀತಾರೆ, ಇದನ್ನ ಹಾಕಬೇಕಾಗತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಎಷ್ಟಿದೆ, 50 kN ಇದೆ. ಇಲ್ಲಿ ಎಷ್ಟಿದೆ, 50 kN ಇದೆ. ಇವು ಎರಡು ಸಪೋರ್ಟ್ ಪಾಯಿಂಟ್ ಎ, ಪಾಯಿಂಟ್ ಬಿ. ಸೊ ಇದನ್ನ ನಾವು ಎ ಡ್ಯಾಶ್ ಅನ್ಕೋಣ, ಇದನ್ನ ನಾವು ಬಿ ಡ್ಯಾಶ್ ಅನ್ಕೋಣ. ಈ ಪಾಯಿಂಟ್ನ ಈ ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟಿದೆ, 1.4 ಮೀಟರ್ ಇದೆ. MM ಅಲ್ಲಿ ಎಷ್ಟಾಗುತ್ತೆ, 1400 mm ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟು, ಇದು 100 mm ಇದೆ. ಇಲ್ಲಿ ಎಷ್ಟಿದೆ ಡಿಸ್ಟೆನ್ಸ್, 100 mm ಇದೆ. ಹೀಗಿದೆ. ಸೊ ಈಗ ಇದದ್ದು ನಾವು ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ ಅಲ್ವಾ. ಸೊ ಅದಕ್ಕೆ ಒಂದು ಇಕ್ವೇಶನ್ ಇದೆ ನೋಡಿ, ಇಲ್ಲಿದೆ ನೋಡಿ. ಜಸ್ಟ್ ಇಕ್ವೇಶನ್ ನಂಬರ್ ನೋಡಿ, ಇಲ್ಲಿದೆ ಇಕ್ವೇಶನ್ ನಂಬರ್ 3.4b ಅಂತ ಇದೆ ನೋಡಿ. ಸೊ ಇಲ್ಲೇನಿದೆ ನೋಡಿದೆ, ಹಾಲೋ ಶಾಫ್ಟ್ ಅಂತ ಇದೆ. ಇಲ್ಲಿದೆ ನೋಡಿ, ಔಟ್ಸೈಡ್ ಡಯಾಮೀಟರ್ ಆಫ್ ದ ಹಾಲೋ ಶಾಫ್ಟ್ ಸಬ್ಜೆಕ್ಟೆಡ್ ಟು ಸಿಂಪಲ್ ಬೆಂಡಿಂಗ್ ಅಂತ ಇದೆ ನೋಡಿ. ಸೊ ಈ ಇಕ್ವೇಶನ್ 3.4b ಇಕ್ವೇಶನ್ ನಾವು ತಗೋಬೇಕಾಗತ್ತೆ. ಇಲ್ಲಿ ಇದು ಸಾಲಿಡ್ ಶಾಫ್ಟ್ ಆಗಿರೋದ್ರಿಂದ, ಹಾಲೋ ಶಾಫ್ಟ್ ಅಲ್ಲ, ಇದು ಸಾಲಿಡ್ ಶಾಫ್ಟ್ ಆಗಿರೋದ್ರಿಂದ ಕೆ ವಿಲ್ ಬಿಕಮ್ ಝೀರೋ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇಷ್ಟು ಪಾರ್ಟ್ ಬರೋದಿಲ್ಲ, ನಮ್ಗೆ ಬರೋದು ಎಷ್ಟು ಪಾರ್ಟು, ಬರೀ 32m ಡಿವೈಡ್ ಬೈ ಪೈ ಸಿಗ್ಮಾ ಡಿ ಬರುತ್ತೆ. ಇದು ಡಿಒ ಬರುತ್ತೆ. ಸೊ ಡಿಒ ಅಂದ್ರೆ ನಮಗೆ ಡಿನೇ ಇವಾಗ. ಸೊ ಏನಾಗುತ್ತೆ ಇಕ್ವೇಶನ್, ನಮ್ಗೆ ಕೊಟ್ಟಿರೋ ಇಕ್ವೇಶನ್ ಏನಿದೆ, ಅದು ಡಿಒ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಿದೆ, ಥರ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಇದೆ. ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆದ್ಮೇಲೆ ಏನಿದೆ, 32m ಇದೆ. 32m ಇದೆ. ಆಮೇಲೆ ಇಲ್ಲೇನಿದೆ, ಪೈ ಡಿಒ ಕ್ಯೂಬ್ ಇದೆ, ವಿದಿನ್ ದ ಬ್ರಾಕೆಟ್ 1 ಡಿವೈಡ್ ಬೈ 1 ಮೈನಸ್ ಕೆ ರೇಸ್ ಟು 4 ಇದೆ. ಆಮೇಲೆ ಇಲ್ಲೇನಿದೆ, 1/3 ಇದೆ. ಹೌದಲ್ವೇ. ಸೊ ಈ ತರ ಇದೆ, ಹೋಲ್ 1/3 ಇದೆ. ಸೊ ದಿಸ್ ಇಸ್ ದ ಇಕ್ವೇಶನ್. ಬಟ್ ಇಲ್ಲಿ ಇದು ಹಾಲೋ ಶಾಫ್ಟ್ಗೆ, ದಿಸ್ ಇಸ್ ಫಾರ್ ಹಾಲೋ ಶಾಫ್ಟ್. ಬಟ್ ಫಾರ್ ಸಾಲಿಡ್ ಶಾಫ್ಟ್ ಏನಾಗುತ್ತೆ, ಫಾರ್ ಸಾಲಿಡ್ ಶಾಫ್ಟ್ the outside and inside, there is no inside diameter. So when there is no inside diameter, K will be 0. There is no K. So when the K is 0, then what you get is, for D is equal to ಏನಾಗುತ್ತೆ, ಈ ತರ ಆಗುತ್ತೆ, 32m, the capital M, divided by pi DO cube, ಇಲ್ಲಿ 1/3 ಆಗುತ್ತೆ. This is for solid shaft. This is for solid shaft. This is the equation. Okay. So here, what is M? ಇಲ್ಲಿ DO ಅಲ್ಲ, ಇದು once again D. ಇದು DO ಅಲ್ಲ, ಇದೇನಿದು, ಸಾರಿ, ಇದು pi d cube ಅಲ್ಲ ಏನಿದೆ ನೋಡಂತಾರ್ರಿ. just hold on. It is sigma d. It is not a sigma d. So that is not d. Here this is not do cube. This is not do cube. This is sigma d. Also same thing. This is not d cube either. It is sigma d. Sigma d. That is allowable bending stress. Sigma d is allowable bending stress. So here, what is d? D equal to diameter of the shaft. Diameter of shaft. All right. And what is m? M is maximum bending moment. Maximum bending moment. Right. And then what is sigma d? Sigma d is, it is allowable bending stress. Allowable bending stress for shaft material. For shaft material. All right. Okay. Now, so we have to, with the sigma d is given now. Only thing we have to find out this m. Only thing we have to find out this m. How to find out the m? So if you have learnt SOM, you should know the procedure to find out the maximum bending moment. So let us now start doing it. Let us once again draw the sketch free body diagram. So it is like this. So here you got a 50 kilonewton. Here also you got 50 kilonewton, and then here it is A point. This is A and this is B. Let it be A dash, let it be B dash, and this is 1400 mm, and this is 100 mm. This is once again 100 mm. Okay, now first step, bending moment. So you need to find the reactions now. First, before finding the bending moments, you need to find the reactions at point A and point B. So you have to find out reactions at point A and point B. For that, assuming, so the first step is assuming the system is in equilibrium. What are the conditions? The first condition is sigma h is equal to 0. Second condition is sigma v is equal to 0. Third condition is sigma m is equal to 0. What does it mean? It means all the horizontal forces, those are acting on the system. This is a system, force system. So all the horizontal forces acting on the system must be 0. Sum of all the horizontal forces acting on this system must be 0. Then only we can call it as equilibrium. Then the next is sigma v equal to 0. What does it mean? It means all the vertical forces like 50 kilonewton, and let us consider here a force acting, that is Ra, another force acting here Rb. So these are the reaction forces. So summation of all these vertical forces, that is 50 kilonewton down, Ra up, Rb up, 50 kilonewton down. Summation of all these forces must be 0. That is second condition. Third condition, the moments due to all these forces, the sum of moments of all these forces acting on the system must be 0. So now, as per second condition, that is as per sigma v is equal to 0, what we get? We get R 50 kilonewton is 50 kilonewton plus 50 kilonewton. These are both down, and then Ra, let it be, it is upwards, that is minus Ra. Rb is upwards, therefore it is Rb is equal to 0 as per this rule. Then what happens? It is now 100 kilonewton minus Ra minus Rb is equal to 0. Now what happens? Now let us move this RA. Let us move this RA and RB this side. Now what happens? We'll move this to here. So the symbol will change. The negative symbol will be changed to positive symbol now. Now what happens? Let it be 100 kilonewton here. If they go here, it becomes RA plus RB. So RA plus RB equal to 100 kilonewton. Since they are symmetric, the here you can see here the distances from this point and this point, this point and this point are all same 100 mm, 100 mm. So hence RA must be equal to RB. Hence RA must be equal to RB. So then what happens? RA must be equal to RB. Then what happens? 100 kilonewton is equal to RA plus RA. It is 2 RA. So RA will be equal to RB. That will be equal to 50 kilonewton. Right. So now this is now 50 kilonewton. This is also 50 kilonewton. You can actually, if it is not symmetric, then RA will not be equal to RB. RA will not be equal to RB. Then you have to go for sigma m equal to 0. Then you have to take the bending moment at each point, or actually bending moment at this point. I will show you that also. If it is not symmetric, assume that it is not symmetric. Now it is symmetric. If it is not symmetric, then what to do? Then to find out RA and RB, you need to take moment at point A. Take moment at point A. Then what happens? Now, here you need to find out all the forces those are acting. Now, start from this point, that is 50 kilonewton, and it is the moment is like anti-clockwise, right? Anti-clockwise. Let us take it as negative. So let us take it as negative. So anti-clockwise is negative. So what is the formula to find a moment? That is 50 kilonewton into 100 mm. That is negative. And the moment due to this force, that is RA, will be 0. Let it be. Then the moment due to this RB, this will also be anti-clockwise. See, this is also anti-clockwise. That is negative. That is RB. What is the distance between these two? That is 1400. Next force is 50 kilonewton, and it is clockwise. See, this is clockwise. The moment due to 50 kilonewton is clockwise. Hence, it is positive. That is 50 kilonewton. What is the distance? The distance between this point and this point, it is 1400 plus 100, that is 1500. So this will be 1500. Okay. Now what do you get? Now here let it be simply 50. 50 into 100 minus RB into 1400. Here let it be 50 into 1500. So now this will be this should be equal to 0, isn't it? This should be equal to 0. Now what is going to happen? Let us move this RB into, this is negative. Let us move this here. Now it will be positive. Now it will be 50 into 100. This is negative, no? This is negative. Negative plus 50 into 1500 is equal to RB into 1400. All right. Now what do you got? Now here Let us take the calculator. Let us take the calculator. The calculator is here. That is 50 into 100 is 5,000, right? Negative 5,000. Negative 5,000 plus 50 into 1,500. 50 into 1,500 is 75,000 is equal to RB into 1,400. Now what you got? Now here 75,000 minus 5,000. What you got is you got 70,000. You got 70,000 here is equal to RB into 1,400. Now what is RB? RB equal to 70,000 divided by 1,400. So what is this answer? Divided by 1,400. So you got 50. You got 50, right? 50 kilonewton. So this is why, this is how you have to find the reaction values, the values of reaction force Ra and Rb, if they are not symmetric. Since they are symmetric, I have already used my analytical skills and I have said that Ra equal to Rb equal to 50. If you cannot judge properly, then you can use this method to find the values of Ra and Rb. Similarly, you can once again calculate. So if once you know the Rb value, you can also already find, you can you very easily find Ra value, because here you have an equation, see, that is Ra plus Rb equal to 100 kilonewton. So Rb value is 50 kilonewton, means Ra value should be 50 kilonewton. So you can usually find, that is we know that Ra plus Rb equal to 100 kilonewton. It is already given. Ra plus Rb is already 50, that is equal to 100 kilonewton. So Ra value equal to 100 minus 50. This is equal to 50 kilonewton. All right. So Ra value will be equal to 50 kilonewton. So Rb value is also once again 50 kilonewton. So this is how you have to find out. So once you find out the reaction values, you have to find out the maximum bending moment. How do you do that? Once again, we will draw that sketch here. Next procedure is finding maximum bending moment acting on shaft. That is what? That is capital M. That is capital M. The first step is we'll draw that one, that free body diagram once again here, like this. 50, 50. Here also it is 50. Here also it is 50. So this is A dash, this is A, this is B, and this is B dash. Now you have to find out, first step, bending moment Bm at A dash. It will be 0. You have to find out only the right side or left side values. You have to find out, you have to only consider the left forces or the right side forces. So now I will consider the right side forces. So the right side forces are, now you have got 50 and this distance is 100. This is 1,400 and this is 100. All right. Now the distance between this point, this force 50, and this point are what? It is 100, right? So, and it is anti-clockwise direction. So let it be negative. 50 into 100. 50 into 100. All right. So yeah, the force, the moment due to this force 50 is actually like this, right? Right. It will be anti-clockwise. Okay. Next, there is another force. This force, that is this force 50. This is also once again anti-clockwise, right? So directions are like this. So once again negative, and that is once again 50. What is the distance? That is 1400 plus 100, that is 1500. Next, what is the value? This is the this is 50. This is clockwise. So that is clockwise means 50. That is 50 into what is the distance? Distance is 100 plus 1400, 1500 plus 100, 1600. Basically, you will get 0 actually, but I am just showing you how to do this. So this is a minus 5000, and this is minus 75,000, right? And then plus 16,000 to 80,000, right? This is 80,000 plus 80,000. Now what you got? Here it is 80,000 minus 80,000 plus 80,000. So what you get? You get 0. So bending moment at A dash is 0. Next you have to find out bending moment at second step. Bending moment at A. So now, as I already told you, you should not now consider the left side values. Left side you got this force. You should not consider this force 50. You should only consider the forces which are on the right side. So there are only two forces now, this 50 and this 50, right? What is the value now? Now let us see. Okay. The moment due to this force, that will be anti-clockwise, right? So negative value 50 into, just hold on, I have not properly written this. So it is 50 into distance is 1400. Next, what is this value? This is 50 and it is clockwise. So clockwise means plus 50 into distance is 1500. All right, because see you got 1400 here and 100 here, 1500. So from this distance, from this point to this point is 1500. Okay, what is the value? 14,400 into 50 is 1400. Oh, sorry, 1400 into, so this is the problem, cancel, 1400 into 50 is 70,000, right? This is negative, this is negative 70,000 plus this is 75,000 plus 75,000. So what you get is you get positive 5,000 Newton meter at A. Similarly, third step, BM at B, bending moment at B, Once again, so you have to only consider only the right side force, that is only 50. You should not consider left side forces. So this is only 50 and it is clockwise. Now what is the bending moment? That is positive 50 into 100. That is once again plus 5,000 Newton. You can also consider the bending moment, fourth step, bending moment at B dash. So this is, there is no force. See, after B dash, there is no force at the right side. That means bending moment at B dash is 0. It is 0. It will be 0. So now what is the maximum bending moment? The maximum bending moment value is 5,000 Newton. The from above calculation, maximum bending moment on the shaft is M, that is equal to 5,000 only, 5,000 Newton meter. So now we have found out the maximum bending moment. Now we have to use this formula. We have to now use this formula, that is D equal to 32m. This formula we have to use now. Now we have to use this formula, that is D is equal to within the bracket 16m pi sigma D 1 by 3. This formula we have to use. So that is not 16m, right? So this is not 16m, this is 32m, you can see here. So the formula is not correct. So we have to change this. This is not 16m, this is 32m. This is 32m. So now here it will be this will be 32. So this value will change, and this value will also change. All right. So this is 32. Now 32 into 5000. So let us make it 0. Make it 0. Cancel it. So what you got is 32 into 5000 is 1,60,000. So 1,60,000. So divided by 314 is equal to 509.5. This is 509.5 minus 6. All right. Now you have to find out the value of this. This is into 10 raised to within bracket minus 6 bracket close is equal to yeah, this is the value, and the cube root of that 1 by 3. Yeah, that is 0.0798. 0.0798 meter. In terms of mm, it will be 0.0798 into 1000. So into 1000, it is 79.87. It is 79.82 mm. So if you go to the standard chart, this chart, so 3.5a, so that is 79 point, there is no 79, right? 71, there is only 80. So we have to consider 80. So this is approximately 80 mm as per table 3.5a. So in this way, you need to solve this problem. So this is a special type of problem in which the shaft is acted upon by bending loads, not the twisting loads. So I will summarize the problem. You have to first find out, you have to first convert this type of this is the actual realistic scenario. This you have to convert into this force diagram, and then you have to find out the reaction forces at point A and point B. And then once you find out that, I have found here. So this is the force diagram, and taking moment at point A, um, I have found out. So in while finding out the values of RA and RB, you have to consider both the left side forces and the right side forces. The moments those are acting on while finding the moments. So you have to consider both the left side forces and right side forces. The moment due to this force and moment due to this force and this force you have to consider while finding the values of RA and RB. That is called as moment diagram. While calculating the moment acting on a moment of forces acting on the system, then you have to find out acting at a point on the system. You have to consider both left side forces and the right side forces. Right side force like RB and 50 kilonewton. Once you find out the values of RA and RB, then you have to assume that assuming the system is in equilibrium, sigma h equal to 0, sigma v equal to 0, sigma m equal to 0. So here there are no horizontal forces, hence it is first one is okay. Second one is sigma v equal to 0. There are vertical forces acting, that is 50 kilonewton, RA, RB and 50 kilonewton. These are moving up, these are pointing upwards, and these two are pointing downwards. Hence, the downward forces are considered as positive and upward forces are considered as negative. See, negative, negative, and these are positive, positive. So you get this equation, that is RA plus RB equal to 100 kilonewton. And now you have found out the value of RB here. Put the value of RB in this equation, you will get the value of RA. But since this is a easy scenario, because the forces here are symmetric, hence the value of RA and RB will be equal to the value of this 50 kilonewton and 50 kilonewton. That is what I did here. But if in some case, in exams, if a force diagram is given which is not symmetric, then you have to use this method. Taking moment at every point, you can find out the value of RA and RB. Once you find out the value of RA and RB, you have to find out the moment, the bending moment. Now the bending moment at each point, that is at point A dash, point A, point B, and point B dash. While you are in the process of finding the bending moment, you have to only consider one side forces, either left side force or the right side force. Now in this example, I have considered only the right side forces, not the left side forces. So this is very important. While finding the value of RA and RB, you will find the moment of the forces acting at a point. Moment of all the forces acting at a point. While doing that, you have to consider both the left side forces and right side forces of that point. But when you want to find out the bending moment at a point, then you have to only consider the right side forces or the left side forces. So in this example, I have considered only the right side forces. See here, bending moment at bending moment at A dash. So I consider all the forces. A dash means this point. So what are the forces on the right side? You got 50, you got another 50, you got another 50. So I consider all these forces. This force, the moment due to this force is actually anti-clockwise. Anti-clockwise is considered as negative. So I have taken negative 50, and then the distance is 100. So I multiply by 100. And I have considered this force. This is 50. This is also anti-clockwise. What is the distance? 1400 plus 100, that is 1500. So this force, the moment due to this force is clockwise, hence it is considered as positive. What is the force? 50. What is the distance? 100 plus 1400, 1500 plus 100 is 1600. So the bending moment at this point is 0, right? Similarly, I have found the bending moment at point A, point B, and point B dash. At point B dash also bending moment is 0. At point A it is 5000 Newton meter. At B it is once again 5000 Newton meter. So you have to pick the maximum bending moment among all these bending moments. Once you find the maximum bending moment, then you have to use this formula. That is this. This D is equal to 32m divided by pi into sigma D raised to 1 by 3, where sigma D is the allowable bending stress of the material used to manufacture the shaft, and m is the maximum bending moment. So this is already given. I used that in here. M is 5000 and sigma D is 100 megapascal. So I did it. I got it in a meter, but I should convert that into mm. That is why I multiplied this with 1000, because 1 meter is equal to 1000 mm. So that is why I multiplied this with 1000. I got it in mm, 79.882 mm. As per the table, standard shaft size table, that is 3.5a, we don't have 79.82, we have 80 mm shaft, so we have considered 80 mm shaft. This is how you have to solve the problem. Thank you very much.